In this video, we are going to discuss how to calculate the net electrostatic force acting on a charge using superposition principle. Let us start with concept check 1.8. Consider three charges placed along the x-axis as shown in the figure. The values of the charges are Q1 equals negative 8.10 microcoulomb, Q2 equals 2.16 microcoulomb, and Q3 equals 2.16 picocoulomb. The distance between Q1 and Q2 is D1 as shown in the figure here, which is 1.71 meter. And the distance between Q1 and Q3 is D2, which is 2.62 meter. What is the magnitude of total electrostatic force exerted on Q3 by Q1 and Q2? So let us first write down the magnitude of these charges. I have Q1, which has a charge of negative 8.10 microcoulomb. Micro has a multiplier of 10 to the power negative 6. So I'm going to multiply this charge with 10 to the power negative 6 coulomb. Q2 is 2.16 microcoulomb. So again, multiply this with 10 to the power negative 6. And Q3 is 2.16 picocoulomb. Pico has a multiplier of 10 to the power negative 12. So I will multiply this charge with 10 to the power negative 12 coulomb. We need to find the net electrostatic force on charge Q3 because of Q1 and Q2. So let us first sketch the forces acting on charge Q3. Now Q3 is a positive charge, whereas Q1 is negative. So Q1 will attract Q3 towards itself. Therefore, Q3 will move to the left because of charge Q1, and we will write this force as F13, which is force of charge 1 on charge 3. Q2, on the other hand, is a positive charge. So Q2 and Q3 will repel each other. And because of Q2, Q3 will be pushed away to the right. And we will write this force as F23, which is force of charge 2 on charge 3. After sketching the forces, we will find the magnitude of these individual forces. I can find these forces using Coulomb's law. So we write F13 equals K Q1 Q3 over R13 squared, where R13 is the distance between charge Q1 and Q3, which is nothing but T2. So I will substitute these values here. K is Coulomb's constant that has a value of 8.99 times 10 to the power 9. I can also write this as 9 times 10 to the power 9. So substitute K here, 9 times 10 to the power 9. Q1 is 8.10 times 10 to the power negative 6. When we are solving for force using Coulomb's law, we don't need to put the negative sign of the charge here. We have to take the absolute value. Q3 is 2.16 times 10 to the power negative 12 over R13, which is D2, and the value of D2 is 2.62 squared. And when you solve this, you get F13 to be equal to 2.29 times 10 to the power negative 8 Newton. We do the same thing to find F23. F23 will be equal to K Q2 Q3 over R23 squared, where R23 is the distance between charge 2 and charge 3. And we can find R23 by taking a difference of D2 and D1. Because the distance of Q1 and Q3 is D2, between Q1 and Q2 is D1. And I want the region over here between Q2 and Q3, which you can get by taking the difference. So we write R23 as D2 minus D1. So let's substitute. K is 9 times 10 to the power 9. Q2 is 2.16 microcoulomb, so times 10 to the power negative 6. Q3 again, it is 2.16 picocoulomb, so 10 to the power negative 12. R23 is a difference of D2 and D1. So D2 is 2.62. D1 is 1.71 squared. And when you solve this, you get F23 to be equal to 5.07 times 10 to the power negative 8 Newton. After finding the magnitude of individual forces, now we can use superposition principle to find the net force. The net force will be the vector sum of force F13 and F23. And when we are taking the vector sum, we have to take the sign into consideration. We know that any vector going to the right must be taken positive, and the ones going to the left must be taken negative. So here F13 is going to the left, so I will write it as negative F13, whereas F23 is to the right, so I will write it as plus F23. Let's solve for this. F13 is minus 2.29 times 10 to the power negative 8 plus F23, which is 5.07 times 10 to the power negative 8. And when you solve this, you get the net force to be equal to 2.78 times 10 to the power negative 8 Newton. Now, this is the magnitude of my net force. If they ask you to find direction, since the final magnitude comes out positive, the direction here will be to the right. And if this magnitude came out to be negative, the direction would be to the left. Let's try another problem. 3-point charges A, B, and C are situated along a straight line. What is the magnitude and direction of the net force on charge A? So let us first write down the magnitude of these charges. I will write QA to be equal to 6 microcoulomb. Micro again, you have to multiply this with 10 to the power negative 6. QB is negative 3 microcoulomb. So negative 3 times 10 to the power negative 6 coulomb. QC is 8 microcoulomb. So 8 times 10 to the power negative 6 coulomb. Then we sketch all the forces acting on charge A. Charge A is a positive charge, whereas B is negative. So A will be attracted to B, and therefore, because of charge B, A will move to the right. And we call this force FBA, force of charge B on charge A. C, on the other hand, is a positive charge, and it will try to push or repel A away from it. So because of charge C, A will move to the left. So this becomes my force FCA. After showing the direction of these forces, we will calculate their magnitude using Coulomb's law. So we write FBA equals KQA QB over RBA squared, where RBA is the distance between charge A and B. Here the distance between B and A is 40 centimeter, which if you write in meter, divide this by 100, you get 0.4 meter. So let's substitute. K is 9 times 10 to the power 9. QA is 6 times 10 to the power negative 6. QB, again, ignore the negative sign when you are substituting for force. You write this as 3 times 10 to the power negative 6 over RBA, which is 0.4 squared. And when you solve this, you get force on charge A because of charge B to be equal to 1.0125 Newton, which you can round it off to 1.013 Newton. Now we do the same thing for charge C. We find the force of charge C on charge A. So K QC QA over RCA squared. RCA is the distance between charge A and charge C. To find this distance, we need to add these two values, 40 centimeter and 80 centimeter. So RCA will become 40 plus 80, which is 120 centimeter. And when you convert this to meter, you divide this number by 100. That will give you 1.2 meter. Now let us substitute. K is 9 times 10 to the power 9. QC is 8 microcoulomb. QA is 6 microcoulomb and the distance between them is 1.2 meter squared. When you solve this, you get FCA to be equal to 0.3 Newton. After we found the magnitude of each forces, now we can solve for net force using superposition principle. So I will write F net to be a vector sum of these two forces. So FBA is going to the right. We will keep it positive, FBA. FCA is going to the left, so it will be negative minus FCA. So now substitute FBA is 1.013, FCA is 0.3. And when you solve, you get the net force to be equal to 0.713 Newton. And since this force is positive, since the value came out to be positive, this is pointing to the right. You can also write this in vector format by writing F net equals 0.173 x cap Newton. So either you can show the direction by saying it is going to the right, or you can write it as positive x cap to denote direction to the right.